LLMs are great, but are they actually giving businesses what they need? And so is this actually going to grow, or was it just a big spark? A spark, sure, a big one, but is it already fading away? As the SVP of engineering, it's really important for me to figure out how we apply this amazing technology in the real world. I think we've all seen the promise of LLMs. We've seen the magic that LLMs can bring. But if it's not actually applied in a way that people can get real value out of, I don't think it's really going to fulfill the promise.
Saurabh, absolute honor to have you on MLST. Welcome.
Thank you so much. It's great to be here.
Tell us about your background.
Been in the industry about 18, 20 years now, and started off with right here in Seattle with Amazon. And I think what I've done from the beginning is large-scale distributed systems focused on big data and machine learning. Started off with a very physical-related application of machine learning, predicting transit times for Amazon. And this was pre-Amazon Prime, so it was quite the growth story from that point on. So then along came AWS, and so I went from applying machine learning in a more bespoke manner to just doing it very large scale from a computing perspective too with AWS. And so ran a few big data and machine learning services in AWS. And I've been doing a series of startups since. So focused on more traditional machine learning a bit with ad tech, and then took the plunge into computer vision, robotics, simulation, for about 4 years with a 3D engine. Unity, you might have used it before.
Oh, yes.
And from then on, I'd been really watching all through that, just how much had been happening in the Transformers world. And so I think GPT-2 to GPT-3 was quite a massive jump. And so I figured that this was really time to jump in with both feet and get going. And so about a couple of years ago, joined Cohere and been having fun ever since.
And of course, Aidan is the CEO of Cohere, and he was one of the inventors of Transformers.
Exactly. Yeah, it's been absolutely fantastic working with him and the entire team. So Aidan, Nick, Ivan, I think all the co-founders have had a really storied history with machine learning. And so it's been amazing just seeing how they think and, all of the strategic contributions that they've made as well. And so not just from a technology perspective then, but really to build a company.
So what do you do at Cohere?
So I run engineering, which is definitely, it's been quite something over the last couple of years. I think, like I like to say, I started pre-ChatGPT, and so the world was a much, I think, calmer, saner place back then. And so while everybody obviously already seen the power of Transformers, what really changed after that was, rather than me telling customers, trying to convince them for 4 hours about why they should use our technology, it was people lining up to say, can you give this to me now? And I think the scale was very different 2 years ago when I started. It's radically different now. And so part of what I do is building the infrastructure. So a large part of my team focuses on how to use these extremely magical but extremely expensive GPUs to really figure out how to do training optimally, how to not just do pre-training but also post-training really well, how to then also do computation for inference very efficiently. And pre-training has obviously grown in size significantly since a couple of years ago. But the inference business has grown by several leaps and bounds. And so figuring out how to do that very efficiently. So the infrastructure part, the serving part, the serving things very efficiently part. So we have a huge focus on model efficiency. And then a bunch of things that relate to the models themselves. And so how we, for example, build our models, train our models, but also how we figure out retrieval in conjunction with the generative models to really provide the best for our customers.
So at AWS, you've got a huge background in data architecture, distributed systems, and so on. How are you leveraging that knowledge at Cohere?
Oh, it's been actually fascinating to see how close the two are. From a computing perspective, I think we started off with a very similar background. With AWS, you had early on people just jumping on because this was never possible before. You had suddenly effectively infinite compute at your fingertips. And then, of course, as you started to do more with it, the bills also started flowing in. And so being able to use that compute a lot more efficiently really became important. And so that's been the story with large language models as well. Initially, everybody threw everything they had at it. And then as they started to figure out really what was, more of a party trick versus what was really critical to their business, people started to take notice and see how they could get more value and then how they could get it a lot more efficiently. So that's really been the focus for Cohere and for me over the last couple of years. And so a lot of the operational discipline that I learned at AWS, I think all of the cloud services really need to run extremely well in terms of availability. Several lines of availability, so they have to be extremely reliable. Several lines of durability, privacy, security. I think all of those lessons apply very well to the LLM world as well. And so, happy to talk about any particular one of those as well. But it's really been uncanny how all of those have translated well to the world of large language models.
Yeah, I mean, maybe we should do infrastructure and utilization first, because in the olden days, I know you used to do a lot of stuff with Elastic MapReduce and Hadoop and stuff like that. And of course, we were on-prem then. We had commodity hardware lying around, and we wanted to come up with ways of utilizing all of these, idling computers. The cloud comes along, and now we have millions of people with their own subscriptions, hiring out entire GPU machines, which are just sitting there all of the time. But
That's right.
Maybe as a provider first, how do you actually optimize that?
Yeah, that's a great question. Yeah, I think AWS started off, for example, with these small machines, just a lot of them, and spread out all across the world. And so figuring out how to actually get enough to do one large job was actually quite something. This is where innovations like Spot, so preemptible machines and so on, came up, right? At Cohere, we've been thinking of that from a inference perspective as well. Customers obviously have varying needs from an inference angle. Some even when they're using the cloud, don't necessarily have enough volume or enough rates sustained all the time. What they want really is to be able to use what they want, when they want, in the right customized fashion. And so, to give an example, some of our largest customers have not just the use of our R and R plus generative models, but also our embeddings models, rerank models. And so all of these on ideally the same hardware. And so as little of a hardware footprint as possible. Then you have fine tuning. So we offer, few layer fine tuning. We offer full fine tuning with our models. And so when you can get a model that's as small as possible, which means it's naturally more efficient, it's actually going to give you significantly more in terms of bang for your buck for hardware utilization. If you can get that to do exactly what you want, and so be able to give you what a larger model might be able to do just out of the box, but in a more customized fashion, you can actually get that high performance at a much lower cost. And that, if you do that really well, you might have several different fine tunes. But now you have, say, a few dozen fine tunes, and now you also need those many GPUs, say, to run them. Then suddenly the costs again go through the roof. So one of the innovations that we came up with was being able to run several fine tunes on the same GPU. And so we have literally customers who are running 50 fine tunes on one single GPU. And so that lets you get away with as much customization as you want, and yet keep the footprint as if you were just running a single one. So that is the best of both worlds, I think, being able to get exactly what you want, but also pay as little as possible.
Because you mentioned doing multiple fine tunes on a single GPU. Now might be a good time to talk about the economics of models, because you can make models as big as you want. You could build a 1 trillion parameter model,
and people have, yeah.
It's completely impractical, because the great thing about Cohere is pragmatism. So, you've got a SaaS, you've got a PaaS, you've got an on-prem. Customers can do what they want, and they can take your stack and they can drop it, into their technology system. So you don't really want to have huge models, do you?
Yeah. We don't. And, we've toyed with the idea. We've definitely built models that are very large as well. But the first thing that we always have to keep in mind, and that served us pretty well, is what do customers actually want? And so, like you said, customers actually want not necessarily the largest model. They just want a model that is serving their needs. And so what they're looking for is real value. And so I like the word that you use, pragmatism, right? I'm a perennial pragmatist. And so if we don't actually give customers what they really value, it might work for a little bit, but they're not going to use this over the longer term. So we are all about the long term. And so building not just for customers, but building with customers. And so early on, we saw that model size was definitely going to be a big factor. And so as the industry just kept going more and more towards larger and yet larger models, it also became apparent that you had models that were very rigid from a deployment perspective. And so customers who really value privacy supremely, potentially even above everything else, were keeping their computation as well as their data inside the network. And so the fact that you now had to send that data to a model that was running somewhere else simply because it could not be deployed to where your data was, that was a strict no-no. And so as we saw retrieval-augmented generation especially growing as a big paradigm, it became more and more critical to get access to this data that was sitting completely on the customer side. And so what we hit upon was, rather than get the data over to the model, we would just bring the model over to the data. And so that necessarily meant that we had to deliver a lot more in terms of performance, quality, abilities in a much smaller package, because there's only so much that you can actually deploy to a smaller footprint at a customer's. Several trillion parameter models are definitely not possible to run on a small footprint. They only work really when you have massively multi-tenant customers or a massively multi-tenant setup to serve those customers. And that just doesn't work for most enterprise customers. In fact, even if you see some of the patterns in terms of cloud computing, many customers insist on wanting to run their workloads in isolation. And so providers who have stuck to only serving this on public cloud are having to figure out how to do that in a manner that befits customers as well. So we just went the whole hog from the beginning. So yes, we started off with a software as a service, so Cohere's own managed hardware. Then going to all of the usual suspects on the cloud, some of which didn't exist actually when we started doing this. So Bedrock came, for example, a lot later. SageMaker existed. We've worked with OCI to actually bring up the OCI Gen AI service. We are a key player on Microsoft Model as a Service on Azure. So we definitely serve customers if that is what they want, if that is where they are. But then we go beyond, and we also serve them on virtual private cloud, on all of these large cloud providers, and then all the way to on-prem.
ML engineering is difficult, right? So, I mean, I was always a fan of DevOps, and just kind of orchestrating across the entire life cycle of software engineering, and a lot of it is not just things you can automate. It's instilling human processes and workflows and operating models and so on. ML DevOps is even harder because the curves are different. You're sort of like managing the impedance mismatch between what is basically science and engineering. And also when you get to enterprise customization and data platform, there's like the operational world with line of business applications, there's the analytics world. And what the cloud providers try and do, I think, is box you in. So they create things like Azure ML, SageMaker, Bedrock, and they're trying to commoditize what you do. So you almost become a kind of client of the cloud. But the reality is, every time you try and templatize or in a formulaic way say, well, this is what a traditional AI solution looks like, it's brittle. It doesn't work. Every customer has very unique requirements. Yes. How do you navigate that?
That's a great question. Yeah, just MLOps as a discipline has evolved so much over the last several years. And I think it started off obviously with more traditional machine learning. And so, say more recommendations and personalization and so on. So much smaller models. But it's a completely different ballgame now, with even the smaller LLMs actually still having a pretty significant footprint. And with the expense as well as lack of availability on GPUs, right? So trying to manage a sprawling set of models, potentially different ones for different workloads, trying to manage versions across them, being able to potentially go across providers, all of that matters quite a lot. I definitely think the cloud services are trying to make this better. And as an ex-cloud guy myself, we've definitely fought hard to make it easy for the customer. But I think with large language models, I think there's potentially a different paradigm that's required. And so you have to think in terms of what the customer really, you have to observe what the customer is doing, what the life cycle really is for these models. You mentioned something that really relates to stickiness. And so, if a customer has a really strong model, if they have something that works really well for the use case, they shouldn't be forced to move off of it simply because the provider decided to, bump up the version, right? It causes significant problems downstream for the customer as well. We still have customers running our Command 1 model simply because it's working so well for them. And so the fact that we could actually customize that model for them and tailor it to exactly the use cases that they needed in production to work very well means that they're loath to actually get off of it. I'm sure they will at some point, just because we have so many more capabilities with the newer models now. But the point is, if you actually make it operationally really, really easy and really, really efficient to work with a given model, that's what customers want. And so you ideally do want that stickiness. You do want customers to be able to keep using it for as long as possible. You just don't want them to be forced to do that. And so having that flexibility, being able to actually switch if and when you want, really does matter.
Yeah, an interesting topic here is people think that language models are this magical black box, and essentially everyone's in the token game. You can just interchangeably swap them out. In fact, lots of companies that do AI, they have a drop down and they say, oh, do you want this model? Do you want this model? The reality is it's not really like that.
It's not. It is absolutely not. Yeah, I think this has been this is the biggest shock that most folks dabbling with Gen AI now get. Because they see this wide array of options, they just get started with one model, and then when they see that there's some issues with that model, they potentially just switch to the other one, expecting to get all of that plus some other things. It doesn't quite work that way. And I think honestly, as an industry, we have to fault a bit for that, because we rely so much on benchmarks. And benchmarks do serve a purpose, but they're not enough. And especially serving enterprise customers, which has been the central piece for Cohere for all this while, we've seen that benchmarks give one side of the story. They're useful to gauge certain things, certain abilities, and then be able to compare on that ability across models. But they're just a fraction of the actual story. And so for a given customer, for a given use case, you really need to have the right evals. You really need to have the right set of tests that matter for your particular product, that matter for your particular use case. And having a really well thought out evaluation framework, having a great harness, having all of the right use cases with the right breadth matters a lot, because that's really how you know if a particular model is working for you or not. And when customers switch, say, from another provider to Cohere, the first thing they usually say is, it doesn't work exactly the same way. It's like, it shouldn't. It's not the same model, and you're switching for a reason. What exactly is different? And so usually starts off with just a bit of prompt engineering, which is easy enough to do. We actually even have an auto prompt tuner that can give you, just that saves you the trouble of doing this, because for some reason, I think everybody's expecting engineers to automatically learn prompt engineering, which is just not a thing. I really hope that phase goes away. The model should be able to figure this out. You shouldn't need to have to keep modifying prompts to get them just right. The model should be able to solve this. But even once you're through the prompt engineering phase, the results are not necessarily the same. And that is actually what you want, but that's not what you expect. So if you're just running standard evaluations or standard benchmarks, that's not really going to give you the whole story. So then when we dig one layer deeper, we actually find out that they don't necessarily have enough to show what is really critical for their use case. So we often help them build that suite. Then, irrespective of prompt engineering, when you run that across multiple models, you see that this model actually works really, really well for my use case. And quite often that does require customization. And so that's the journey. And you have to start with what the customer wants and then ensure that they're really getting it. Ideally, with as little effort as possible, but definitely not stopping until you actually get the right results.
It's interesting that you brought up the auto prompting. I think people have this conception that they download a bunch of weights from Cohere and then that's it. They do everything themselves. But it's so much more than that. So there's a whole, I guess you can call it a controller framework, but an SDK, which does a whole bunch of stuff. The model itself actually has a whole bunch, for example, with RAG, it's got citations of verification built into it. And also you ship your entire, like your model serving code and stuff like that. So there's actually an entire ecosystem that you give to the customer, which is basically the same code that you do on your SaaS.
Exactly. So I think that's such a big differentiator because I think if you just come into this completely, without any background knowledge of LLMs, you're going to see a bunch of proprietary model providers. You're going to see some open source models floating around, and you have really good models on both sides. So what really sets us apart, I think, when you see the deployment options that we have. We spoke of having a software as a service API-based approach going towards cloud providers and then all the way on-prem. You're absolutely right. We're not just shipping the model weights. And so, sure, you can download the model weights if you want. We actually publish ours for research purposes on Hugging Face. And so you can just download the model weights and get started. But that's not the most efficient way of actually using the model. So we don't just ship the models to our customers. We actually ship the entire stack. This is the same stack that you actually get on our Cohere managed software as a service platform that has all of the innovations in not just the model itself, but making the model work really well with data sources for RAG, being able to serve the model extremely efficiently, being able to get all those fine tunes, onto a single GPU, like we spoke earlier. You get to take advantage of all of those because all of that is containerized and then shipped to wherever you actually want to run the model.
Yeah, that's really interesting. But still, though, even though we're shipping a whole bunch of the stack, what does it look like? I mean, in terms of complexity, what is the difference now? If I want to build an AI application in the enterprise, how does that compare to traditional software?
That's a great question. I think it differs in several ways. I think the two that probably stand out for me, one is just the ability to call the model no matter what the environment. And so we spoke of the privacy aspect a little bit. I think when LLMs began, everything was relying pretty much on just the model weights. And so you pre-train this amazing model. It's able to effectively speak like a human. It has these superhuman abilities to summarize things really well, to be able to generate effectively what you want. But what it's relying on is really what it's been taught so far. So all of the data that's gone into pre-training, that's the extent of the knowledge it has. Where we really extended that is with retrieval-augmented generation. And so it's exactly what it sounds like. I wish we had maybe a more a flashier name for it, like a single word or something rather than RAG. But I think the retrieval part almost doesn't get enough credit with retrieval-augmented generation because the generation has been the magic for so long. And don't get me wrong, that's absolutely the core of what we do, right? We have to have an amazing generative experience, but generation on its own only goes so far. It's like traditional machine learning, garbage in, garbage out is always the case with any software system, to be honest, right? And so where we've really made a difference now, and I think what is very different from traditional software or traditional machine learning even to this, is ongoing use of the data that the enterprises have in conjunction with this machine learning. And so this is where our retrieval models really come into play. And so we work with enterprises, for example, that have dozens of different data sources, sometimes hundreds of different data sources. You and I have both worked in the data world for a long, long time. You mentioned Hadoop and so on before with EMR. And there was a reason Hadoop came into existence. It was because you had these massive amounts of data with not really a good enough distributed technology to actually be able to process that data. And then, pretty soon you found limitations with that as well. You went on to the next paradigm with Spark, then came the data lakes and so on. And so there's been amazing growth in that area. we are effectively applying those techniques plus a lot more to now being able to bring data in to really supercharge what you can do with LLMs. And so for a typical enterprise, you have so much valuable and unique data hidden away that you really haven't been able to use that well with LLMs so far, that when we actually provide access to private data sources to our retrieval models, it really opens eyes for customers. And we do that in two ways. So one is just our embeddings models. And so embeddings models are representational models that take your data, convert them into a particular format that's easy for both computing semantic relevance and then actually fetching the data, say via vector database at runtime. And so rather than, you could actually fine tune the model to actually throw all of this data in to just actually make the model know everything. Extremely inefficient, extremely expensive, and obviously the model size keeps growing. So rather than do that, how about we just pull the right data in at runtime? And so with embeddings, we're able to do exactly that. Keep embedding the data that you actually get from these private data sources, and then figure out exactly what to fetch at runtime. The model is the one that's generating the queries, so the model does have to be really good at it. And this is actually where our R and R plus models shine quite a lot. They're built with RAG from the get-go as their primary use case. And so they're able to figure out what would be the most optimal query in order to get the right data based on what the customer is asking and based on which data sources you're pulling from. However, again, as with existing software, you don't want to re-implement if you can help. That, so you don't want to ideally rip out all of your existing data systems, your existing retrieval mechanisms, your existing search methods, and just re-embed everything and use vector databases. Right? That's a lot more additional work. It's a lot more additional expense. And so we actually came up with yet another innovation called rerank. And so our re-ranking models are a flavor of these same embeddings models, but they actually let you get semantic relevance on top of whatever search method you're already utilizing. And so think of it as, you might have a separate method for structured data. So for example, sitting in databases, you might have a separate search and retrieval method for unstructured data, potentially over a data lake or something. If you get results across all of these for a given query, for a given, say, Q&A that you're having as part of a chat session, the model fetches the results from all of these sources. Re-rank, a single line literally on top, lets you semantically re-rank. And so, something that might be usually at the bottom of the search results, but is the most relevant, now comes right up at the top with zero re-implementation. And now that is what really goes to the generative model, so you get the most relevant answer.
Yeah, I mean, enterprise search is such an expensive, complex thing. I mean, at one of my previous companies, we were spending hundreds of millions of dollars on it. We had data platforms on Azure and AWS. And yeah, so the way this is sold is you now have this big data lake, and there's different iterations of this view. It changes every 6 months like fashion. But let's say we've got a big monolithic data set and we a data lake, and we've got unstructured, heterogeneous, multimodal data in there. So there's JSON files in there and documents, and we've got things like SharePoint over here, and we've got some line of business operational databases over here. And usually what happens is we use something like Kendra or Azure Search, and we build a big inverted index, and we can contrast embeddings versus inverted indexes, because I think inverted indexes have a kind of specificity that you don't have with embeddings models. But and then usually what happens when you build these indexes, you run roughshod over all of the security boundaries. So the finance people say, you're not having my data in your index, and you need to give me a security token before you access this. And so even before you get to LLMs, it's already a very complex process.
Yes. Yeah, absolutely. I think this is the very unique set of challenges that come with enterprise data, right? So this is not something you're going to see necessarily with consumer data. Everybody's operating on their own much smaller data set, right? So when Gmail came out with autocomplete, it was fantastic. And so you've always had these sort of features that started off with consumer and then kept getting better and better, but completely different ballgame when it comes to enterprises. And so being able to do enterprise search not as a single large problem to solve, but actually go in a manner that matters for the actual use case. And so, like you said, some use cases actually are completely fine being demarcated just to finance or just to legal or just to a particular department. We do have customers who actually want that, and we respect those boundaries. So being able to deploy in a manner that befits exactly the use case, the security boundary that they have, actually does help them significantly. So some do want that isolation, and they will get that isolation. It goes almost to the degree of personalization that they want. You might want much wider access, for example, to certain personnel in a given department. And so that's the access that we have via RAG. And so you need to delegate access the right way to be able to respect permissions. So you can actually just get enough data. You can't do that if you just throw all of the data into the model itself, obviously. So any amount of extending the training for the model is not going to help you in that case. And so RAG with the right security paradigm underneath actually matters even more. But then managing permissions the right way, you do have a chance for the first time, I think, to actually have data that would have been just permanently siloed now be able to be brought together. So you can actually get insights that you wouldn't have expected otherwise. And one way to really we've had customers often look at results and say that can't be right. Like the model is hallucinating. And for literally exactly that, we have verifiability. So we have citations to show not just the answer itself, but exactly where the answer is coming from. And we've had customers do double take and then click on the link to actually go to exactly where the data was coming from and say, I would have never thought that. And so I think this is really what's possible now. I don't think it was ever possible before. But you do need that trust. You need that auditability. You need that verifiability. And so being able to do that with citations really gets us a lot of the way.
Yeah, if done correctly, this can be transformative because, I mean, you've seen this a million times before, I'm sure. Build these big data platforms, they turn into a data swamp because the whole idea was we can have this cross-pollination, we can have this flywheel effect that, different departments can access data scientists can do rapid experimentation, we can build data products. We've all heard the sales pitch, but it turns into a data swamp. But with a pragmatic approach, right? So we build all of these indexes. The great thing about RAG is that the person doing the search, they can pass a security token. They have role-based access control, so that the stores that they have access to will produce results, and we can do augmented generation. This is actually democratizing access to data if we do it correctly.
You're absolutely right. I think that doing it correctly part is paramount, and so we've taken our time to get to that stage as well. And so we take our time with customers in terms of implementation too. I think not everybody is ready for it yet. I think similar to how people were not really ready when data lakes came along as well. And you're right that I think some of the implementations have definitely misled people because you thought you were going to get insights. You're now mired in this data swamp instead. I think with RAG and especially being able to leverage technology that lets you keep your data exactly where it is rather than having to re-implement or pull the data out, put it in some other place that is more optimized. Having things like rerank really let you keep the data where it is, so you don't have to potentially add things from a storage or additional access and permissions and so on perspective. Keep it where it is and then be able to still execute the queries the right way. That matters a lot. The second part that you brought on was access to the right tools. And that has been a standout for Cohere as well. And I'm really excited about this because I really think along with access to the right data, access to the right tools is what's really going to make a difference in the years to come. And so with R&R Plus especially, tool use has become a central use case for our models and so for our customers. Tool use really opens up a completely different world because not only do you have access to the simpler forms of tools, like, for example, just the ability to search, right? So when a model is actually generating a search query and executing that, say with an internet search provider or on a database, you are effectively using a tool. But I don't think we are just trained to think of search as a tool per se. It's just something we take for granted. But being able to actually perform an action, so being able to construct the right API call, construct the code potentially that actually gives rise to it, being able to execute that call, get the answers, and then actually ladder this in a stepwise manner, that just gives you effectively superpowers. This has not been possible before unless you painstakingly manually constructed it. And the fact that a model can just do that now is just leading to completely new ways of getting insights and hence getting value.
Let's talk about monitoring, diagnostics, and software engineering. So, AWS during your tenure, it really pioneered serverless computing and things like step functions and so on. And this was a great way to do software engineering because we could kind of atomize units of computation, and then we could do diagnostics. We could say, well, there's a failure mode here, and I can kind of see exactly how this happened and so on. And I guess when we start building agent-based AI systems, it'll be kind of similar to the serverless paradigm. So there'll be units of computation, and we can trace how things happened. I would imagine something like that might be used for retrieval use cases.
Yeah. You're absolutely right. I think with agents and being able to actually execute several different steps in order to actually get to the ultimate answer, it's almost like you need a bit of planning. You need, to be able to call the right tools. I think in the past with planning systems in general, it's been you're operating in a single dimension in terms of what is the set of possible things. With tool use and especially with just code execution, you can have effectively infinite combinations. And so being able to get to the right plan does matter. It doesn't have to be a unique plan. It could be something that you just pick one of many options. You don't have to have, not unique. It doesn't have to be the best plan or a single optimal plan as such. But the failure modes are certainly a lot more complex now. So I think as we've gone from single servers to distributed systems, we did that because it was necessary. And so in the cloud, not serverless is just one step even beyond. But even at the beginning, when we went from single computers to being able to do things with distributed systems, we did it because it was necessary. There's probably another parallel over there for the model sizes, because rather than just keep growing the server to the largest one you could, so this doesn't make sense. And it's never going to end anyway. It's never going to be enough. You split this up and you actually do it across multiple smaller, more commoditized units. But the failure modes also grow significantly with that. Now you suddenly have to figure out what could go wrong with a much wider, much higher set of units. And so the failure modes multiply within that as well. I think part of this is just something that we have to work around the model with. So figuring out where can we actually restrict the model from going wrong. And so what are the things that we could take care of for the model itself? Just like the model doesn't have to know everything, and the fact that it's actually using a tool to do things that are specialized because that tool actually knows a lot better. We have to keep some of this, not just diagnostics, but keeping the model, say, on the right track. We have to do it as rails around the model itself. But part of this, interestingly enough, the model is actually able to self-correct. And so that's actually been a fascinating thing for me to say, ask the model to do something. It figures out a series of steps. It goes wrong somewhere. It's able to see that it went wrong. And then it's able to actually rerun and figure out an alternate way and then fix itself. And so it sometimes takes a few tries. It doesn't necessarily get it right even on the first attempt at fixing itself. But the fact that it can actually figure out both the fact that it went wrong and then actually get a better plan, and so be able to actually get the right answer by self-fixing its mistake is fascinating to me. And with the way we are training our models, I'm sure it can actually get significantly better.
I know, but what you're pointing out is that the process is almost becoming quite galaxy-brained, which is to say the model itself can do self-verification, and maybe people might instantiate things like meta-programming, so it actually generates code which runs and it can change its own code. But then there's things like, customers would do customization and remediation, and that can, blow up the complexity of an installation and kind of lock them to a particular model. But you guys, on the platform, you can also do a whole bunch of robustification to kind of to stop that. But there's this kind of sausage factory of complexity, and each level is trying to balance the other.
Yeah, that's and I think it's that phase is inevitable. I think you have to go through that to emerge kind of better on the other side. But yeah, it is a sausage factory right now. I think some of this we are learning, how these failure modes operate, what could be done to actually make the model be significantly better, but also how to build things around them. And so hallucination was a big one, right? Hallucination, I view that as a feature, not as a bug. I think people often, especially when when the models got good enough to be able to kind of cross the uncanny valley in terms of the output that they were producing, it was really hard to tell if the model was hallucinating because just based on the structure, the flow, you couldn't actually say that. But then when you really examined the facts, you found that it was inventing things that really hadn't been. But that's exactly what the model is supposed to do. It's just supposed to put what is the most likely piece of text over there. It's not really trying to figure out if it is quote unquote true or not. But we were able to fix that to a large degree with things like citations. So not just rely on its own internal understanding, but actually to use external sources, verifiable sources, and then also provide the means for verification. And so I'm sure that with tool use as well, we'll be able to do more and more that helps the model actually stay on track, that helps the users determine if something is going wrong. And so if there's a failure mode, also provide helpful information to figure out what went wrong, why it went wrong, and then how to potentially fix it. But ideally, yes, the model would be able to fix it itself as well.
Yeah, I mean, you made a beautiful point that we're now in this paradigm of software where, I mean, I suppose you could argue it's the same before, but epistemic certainty is no longer a given. And then we get a UX problem. Right, because I'm building a RAG system, and even though we have citations and verifications, the problem is laziness. Right, people they anthropomorphize, they trust too much, and they don't check things. And we need to be very careful to check things, but also to design user interfaces to encourage that.
You're absolutely right. Yeah, I think this is getting even potentially more dangerous with things like voice and so on, which are encouraging you to effectively anthropomorphize the system, right? But you're absolutely right. I do think that it's necessary, not just nice, but actually necessary to state when you're actually interacting with a system rather than a human. And that's not to say that humans are not wrong. Humans are wrong all the time. And if they don't know something, they might specifically tell you, they don't know something and they'll look it up and so on as well. You and I have gone through so many customer service interactions, I'm sure, where they didn't know the answer, but they were going to go look it up. But it's not evident that you're talking to potentially a system that doesn't really know right versus wrong or true versus false. And so just keeping that in mind is a big deal. I have kids. I want to make sure that they don't just go into an interaction with a model not knowing that it is a model. And so I do think it's a tough problem. When you're dealing with the enterprise systems, for example, there's a lot of constraints. One simple constraint is just, for example, what form of output is the model actually giving you? So we came up with things like JSON mode. We released it a few weeks ago. Works beautifully to be able to get exactly the kind of output that you need. But with that, the enterprise systems, the product that you're actually interacting with gets still better. And so the output that it's producing is indistinguishable from what would have been potentially given to you by a human. So putting that right up front in big bold letters and then encouraging it. I really like what you said about the UX actually prioritizing this. And so the fact that the UX is meant not just to improve or make the interaction easy, but really enforce trustworthiness is critical to me. So I think trust keeps being the central piece for me in everything we are doing with LLMs. And so this aspect of trust is, I think, often overlooked. And I think it is really, really important to keep in mind.
I know it's such a weird thing, isn't it? It's like with the Tesla cars. The better they get at self-driving, the more likely the user is just to kind of take their eyes off the wheel. And they almost need to say, keep your hand on the wheel, keep your hand on the wheel. Yeah, it's so strange. I suppose there's a similar thing with reasoning as well, that you can explain the steps of your reasoning. But at some point, humans just have this heuristic. They say, well, I'm a bit tired right now. This thing's more likely to be correct than me, so I'm just going to let it get on with it.
completely fascinating, isn't it? So just how we think, and so it's not one single mode of thinking. It's not reasoning as in pure reasoning. Like you said, we use heuristics all the time. We use likelihoods all the time, to be honest. And so I think one part is just whether LLMs can reason. It's a topic fraught with. I think it's a minefield, basically. So I'm not going to jump completely into it, but I do think there's rudimentary reasoning emerging, but it is not the kind of emergent behavior that you see with actual biological evolution, for example. So I still think it is an artifact of how LLMs behave. It's not true reasoning as such. But you don't necessarily need fully true reasoning either to get the sort of outcomes that we need for example, businesses. It does matter a lot depending on the kind of application you're using the LLM for. So if you really want it to think like a human, if you really need it to think like a human, the kind of reasoning that you expect or the kind of reasoning that becomes a must is very different from what you would need for your run-of-the-mill enterprise application. And so I think for the practical set of users, especially with software that are the bread and butter for Cohere, I think the amount of reasoning that the LLM can do, and in this case, I'm including things like being able to just judge what the next step needs to be. Right? We went from almost no reasoning to chain of thought reasoning to then being able to figure out tool use automatically and so on. I think that's more than enough, and we can keep improving in that sense. But yes, reasoning in the sense humans do, or that would be expected for really more life-critical applications, I think that's a bit different. And so I think it's important to keep that in mind and to separate the two as well.
Well, I think this is another great area of pragmatism because we're building human-machine cyborgs. And just like with Gen AI code, the LLMs are these wonderful creative idea generators, and there's usually a human in the loop supervising the process. So we do the selection, we do the verification, and then we fine tune the LLM on that, and we share it with other people in the organization because we're building these distributed apps, and the whole system works really well because it's just using the tool as a technology.
Yeah, this you brought up. Self-driving vehicles a little while back. I think that's exactly how they progressed as well, right? You learned a lot automatically through, for example, computer vision, but there was an enormous amount of annotation going on and a crazy amount of guidance for how the system was actually being built. And this was a lot of what I did before Cohere. And so I think all of those lessons we definitely need to bring over here as well. Part of how we are training the models is, obviously you've heard of RLHF and so on, but it's not just human feedback in the training loop itself as well. It's just even how we teach the model in the first place. And so both reinforcement learning and imitation learning have actually been around for quite some time. A lot of that is how some of the more standout systems have been trained with like AlphaStar and so on, for example. But I think what we're seeing now is understanding just how a particular domain works, understanding how a particular type of use case or a particular vertical works. We can often train the model just enough for that particular domain, for that particular set of use cases in a similar manner. So it doesn't have to be that you're actually putting the model into use and then having to go through the entire cycle in a repeated manner to just train it. You can actually use that as part of the pre-training. So generating synthetic data that is able to actually cater to just that set of use cases or even that set of failure modes is something that has been very, very useful. With Unity, we used to do this thing for computer vision, say, of course, a car going down a particular road. In the daytime is a different story. Nighttime, completely different. In rain, completely different. With a stop sign suddenly in front of it because there was a pothole and there's some repair going on, completely different, right? And so how do you actually generate all these variations? How do you actually teach the model to be able to respond to all of these different cases as well, and not just the, say, most prevalent case? we produce synthetic data for it. So because we could just do that programmatically using the 3D engine, and we're using the same techniques now with synthetic data to be able to fix the things that the model doesn't necessarily know by default, or what is expected in a particular domain but would not be otherwise. So the model doesn't have access to the data that it actually let it understand or let it actually produce the right answers for those type of questions. And so we can do it with synthetic data way more efficiently than just throwing a lot of data without understanding why a particular piece would be more useful than the others. And again, it was the same thing with self-driving vehicles. Initially, everybody just drove millions and millions of miles, and you still didn't hit all of the edge cases that you needed to, because you needed the car to protect against those. And so synthetic data really came to the rescue. And so I think it's the same thing now with large language models.
There's a sea of edge cases, and there's this entire life cycle of model training, because these are foundation models. And what we're trying to do is, you've got these customers, and you're trying to touch the customers in the sense that you're covering, their domain as well as possible. So on your end, you train on loads of data, you do a bunch of data augmentation, data generation, synthetic data, and then the customers will do some fine tuning. And then they'll do remediation. They might do things like test time inference and so on. And essentially, you've got this big kind of tree of customization. And it wouldn't make sense for you to do some things because they're too specific. But by the same token, it wouldn't make sense for customers to train on all of their data.
Exactly. I think picking the right data that is really imparting new ability to the model is very different from what you just need to pull in as evidence, or just need to pull in as factoids that you need as part of the answer. And so a great example is healthcare. A lot of healthcare data, unless it's been specifically made public for a particular purpose, a lot of it is completely private. And so we have customers who are dealing with healthcare data that can't even show that data to us, even for help with actually training, improving the model. And so but the amount of data is significant. And so just throwing all of it into the model definitely would not work. And so we work with them to separate out different kinds of data. Some, for example, just teaching the model more medical terminology because the model has not had access to that, or teaching about specific, for cancer research, for example, teaching it about specific things that occur only in proprietary research that's happening at that particular hospital or that particular institute. Ensuring that it gets enough of that into the model itself. And you'd be surprised at how much can be done by just a very small amount of data for fine-tuning. So literally with a few thousand examples, you can actually go significantly ahead in terms of improving the model's ability. But then other things that it just needs to fetch at runtime to be able to give a good answer, you definitely don't need to put that. But I wish there was a clear way today to just do that programmatically. I think that would make customers' lives a lot easier. I don't think that is quite there yet. Training the model is still very much an art rather than a science. And so I'm actually very happy that we go all the way to the customer. So we are a model provider. We pre-train our models from scratch. We do the instruction tuning on top to get the sort of interaction that we will expect from a question answering angle. We then also help them with their fine tunes, but we go all the way to help them entirely to get the result that they need. Startups especially have to do things that just don't scale. Will this scale to 1 million customers? I don't think so. But it's very critical now, especially at the start of this cycle, to make sure that customers can actually get the right outcomes. And so I'm very happy we have a forward deployed engineering team, which is basically an applied machine learning team, hardcore specialists who've been in the field, who've really spent significant time understanding and almost suffering through what models can do and cannot do, to be able to figure out what is the right technique, what is the right set of tools to be used for customers. And so very happy to say that they've been helping customers get significantly better results.
Yeah. So what's the engagement model?
I think fairly straightforward. You start off with the models themselves. I think based on what's available on our website, based on what you get from our standard materials, you'll be able to figure out the generative family, the embeddings models, the rerank model, and so on. What to use each model for, and then being able to just start out with your use cases, right? Most customers go through this POC phase first to see if this actually fits their use cases at all. And we have enough guidance available to be able to do that. But when you start to go beyond that and say, you know what, this is not enough. I want something significantly better. I want something significantly different. And different could be constraints based on your operational environment. Different could be based off of the particular data sets, the data sources that you need access to. We have connectors for literally 100 plus data sources, but you might still have something different, or you might have different circumstances surrounding your particular instance of a given data source. And then, of course, the big boss, which is the final boss, which is does it actually work for your use case in terms of your evals? And so even getting the evals themselves, setting those up and then running them. So we go, soup to nuts through the entire journey. And sometimes it's a lot more special. So we have our models are multilingual from the get-go. So our embeddings models, for example, support 100 plus languages. The generative models support all of the top 10 business languages, and we're always expanding these as well. But for example, we have a partnership with Fujitsu because even though the model does very well at Japanese out of the box, that's not enough. For the specific use cases that they have, they actually need an even more specialized Japanese model. And so we're actually working in collaboration with them to develop a Japanese model for the Japanese market. And so that will have yet better Japanese capabilities, including things that are very culture specific, that wouldn't necessarily be a thing you would expect from a more general model, nor potentially what you want in a more general model, because the same formality that you expect in Japanese business interactions is not necessarily something that you want, say, in an English or French or German business interaction. And so we help customers all the way through these. And so, some customers, it's more a smaller number of use cases. With customers like Fujitsu or Oracle, it goes significantly further in terms of customization.
Yeah, maybe we should talk about the Fujitsu use case a little bit. So, with your main enterprise customers, you have a forward engineering team. So you have boots on the ground, and these are folks who are absolute experts in your technology. And the interesting thing is it goes in both directions, right? So you're also extracting use cases from them that you can put back into your product roadmap. But one of the risks is that this is quite common with startups, that your top 10 customers, you almost build. You build a monster because you customize their installation so much, and then it almost becomes a fork. How do you balance that?
That's always I think at the forefront of any technology leader, how to not get sucked into that and so go down the wrong path per se. So we've been vigilant about that from the beginning. I think one key thing is to separate out your core training workflow from what is needed on a customer-specific basis. And so we have our core modeling team that is the one tasked with producing our pre-trained models, figure out the right recipe, get to the right set of results, and then also perform post-training on those and so on. We have a completely distinct team that actually works with customers. Now, the two definitely work very closely together because, like I said, what we learn from customers in terms of what is important for us to solve in market, what is actually really valuable to customers, we want to make sure that that goes back into feedback for the model itself. But the timelines are very different. So, for a customer that is really straining to get a particular use case working, they will need a good solution tomorrow. That's very different from the cycle time for a new pre-trained model to actually emerge. And so while we obviously strive to get that back in as quickly as possible, it definitely takes its way through the stages. So we learn from the field. We see what is potentially just a one-off case. What are we seeing on a recurring basis? There's extremely valuable information because we're effectively seeing which way the market is going. And so what are the things that are potentially applicable on a much, much wider scale? And so what would be important to not just this customer or a small set of customers, but a much, much wider set? We obviously run our own processes from a product management and predicting usage perspective as well to see what is valuable, what is not to take back to the model. But then it very definitively makes its way as feedback into building the next iteration of model. And some of this, potentially we are able to do just at the post-training phase. So you might see this, actually get solved on a much more general level at the immediate next, in the immediate next iteration of the same generation of the model. But some are more accretive. And so you accumulate all that feedback. You have to procure data at a much larger scale because you will need that in the pre-training phase to really make a difference. We have our own annotators. We have our own methods for producing synthetic data. And so we might need to produce that data at scale. And then in the next generation, it will actually make it in as an ability into the generative model itself. And then everybody will suddenly be able to get those capabilities. We have to be very careful, of course, in not letting any customer data get in. And so the fact that we keep our installations completely private, for example, in on-prem deployments, just helps naturally with it because customers have the assurance that even though the use case is being understood and being solved, absolutely none of their data has even a chance of making it back into the model.
Do you remember in the heady days of the cloud around 2017, and Microsoft and AWS, almost on a weekly basis, they were launching new services because some of their customers said, "Oh, we want to have a computer vision service," and then I think the guys over in Building 99, they had a server running, and they said, "Here you go, here's a new service," and it's really good because you can kind of like rapidly bring customer requirements and create new services. But the drawback is you're a platform, so you're the generalist, and they're doing specific stuff, and you might then have built this albatross that you're dragging around with you for ages because you have to support it for years. So how do you make those decisions?
Yeah, it is tough. I think we always guard against over proliferation of services. So I think it's a little easier for us probably because we stick to doing one key thing, which is building models and then the right way to serve and apply those models. And so we are careful to use partners where we need that ability for our customers, but it's not really our core competency. And so we would much rather not dive into it ourselves. But yeah, in terms of even model building, we have to be careful with it because I was giving that example of some of our customers still using Command 1. We do have to support that. I think part of it is also the industry tends to just automatically move on to newer versions because you're getting better capabilities or potentially because it is better for the model provider. But enterprise life cycles, software life cycles are much, much larger than that. And so even in past roles, I've had software versions that customers kept using for over a decade. And so it is important to support that. And so when you actually move, for example, the customer from an earlier version to a newer version, to be able to give the kind of support that is necessary so the move is seamless for them, it actually makes sense for them, and that they're, again, well supported with the newer version. So I think one way it just we are able to draw upon the separation of the primary model itself is taking an independent path. It is not really bound to a particular set of customers or a particular set of use cases, but then fine-tunes any customizations that we do. Yes, we do need to provide support on an ongoing basis and also augment them, right? So if something was built on Command 1, and we now need to redo it on top of Command R, on top of Command R+. Yes, we do help the customers with it. I think partly these are solved by just having very disciplined testing, for example. The same use cases might work completely on the new model as well. If you have a smaller number that doesn't necessarily work or that you need to basically work on, then you can still pay attention to those. But being very rigorous in terms of qualification and testing in general has helped us quite a lot. And we instill that into our customers as well. So they often, every customer likes to be independent if they can get away with it. They would rather not rely on us. And so we try to encourage that independence as well. But we are definitely there when they need help.
Another interesting evolution of this technology that I'm interested in is, that you get this kind of progressive disclosure of complexity where you can program at different levels of abstraction, similar to the Keras framework. You can program down to the metal, or you can have, a much higher level abstraction. And do you see this happening with language models? I mean, at the moment, people are just, they're working with text and they're building their own interfaces and they're talking to the model, they're doing prompt engineering. Do you see some kind of low code, no code abstraction where you can just build entire applications and you don't really know about the LLM behind it?
Oh, absolutely. Absolutely. I think that's, we're already seeing that happening, and I think that is absolutely necessary. I think we've seen this, like you said, with many other things in software engineering as well, because ultimately it's a means to an end. I love to program, but I'm not programming just in and of itself for programming's sake. I'm doing it to satisfy some ultimate aim, to actually provide, fulfill an objective. And so that's exactly the case with LLMs, the way I think. I think the fact that you started off with base models, then came instruction tuned models. And so you could certainly chat with the model rather than just having it produce completions. That was a big shift. Chatbots have been around for, I don't know how long. They've been, at least the way I grew up, they've always been around. But the quality is dramatically different now because the technology behind them changed. But for a layperson who is just, going from one chatbot to another, they're still using a chatbot. So the fact that something changed dramatically behind it is what's making a difference, not necessarily the interface itself. And so I think that will really apply for low code, no code, potentially even other modes of interaction with technology itself. And so, even going all the way down to neural interfaces and so on, because I think language is so powerful. The fact that we started off with language means that we have a way to interpret something that is very fundamental in terms of expression for human beings. And so extending that ability to just understand what is being expressed to actually achieving the aim, I think that bridge is what LLMs are really have given us. And so being able to now innovate on top of this bridge that is really reducing the gap between what we want to do to actually achieving it, I think that's going to give us a ton of options going forward. So yeah, I'm really excited about what's happening already at the application stage. We see customers, we have, for example, we just launched a startup cohort with Cohere. And so several of those are really working solely in the application layer and doing things that we never thought would be possible. And so Cohere obviously can't do all of those. We are sticking to what we do best, but then being able to build on top and get completely brilliant implementations across the spectrum of what is a user's ability or a programmer's ability. I think that's so fascinating.
Yeah, I think it's such a big opportunity. I mean, in the large enterprise, certainly in the FTSE 500, software engineering skills are in short supply. And that's why there's a huge market for things like, Microsoft Power Platform and things like ServiceNow and Salesforce. They actually have or even like the Oracle system, they have widgets built in to democratize, building out applications, and they already have pre-built applications that you can use, publish, compose, and so on. And I think cracking that nut, having some kind of a virtual app fabric where you also virtualize things like, cost and cross-charging and security and stuff like that, that would really, really make it easier just for people to get up and running with AI applications.
You're absolutely right. I think the dream for me has always been being able to produce what you want without needing to be an expert in all of the intervening things, right? Because again, it's just a means to an end. And so if you know what the objective is and you can actually get the system to just do it for you in the least effort manner possible, the better it is. And so I think we spent in computer science for so long, we've really done things, I think, backwards. We've effectively trained humans to do things in a manner that computers find easy to do. I think with LLMs, we've completely flipped the script. all of a sudden, Karpati, I think, said this, English is now really the best programming language. I think it's natural language. There's a reason it's natural language. And so for humans, this is the way we think. This is the way we should actually be implementing things as well. And now LLMs let you do things in a manner that is natural to humans rather than natural to computers, and then do the translation for what is required for computers to still actually get the job done. And so this is, I think, just the beginning. So this is what excites me. I don't think it's the immediate applications that we've seen so far, although we're certainly seeing a big groundswell now. 23 was kind of the year of the POC, and then 24 we are seeing so many customers really make the leap from smaller use cases or a small set of use cases or a POC all the way to getting full-fledged in production. We have dozens, if not hundreds of use cases actually in production with large customers that took it slow at the beginning, saw it catching on, saw how easy it was to actually add on more use cases, and with the efficiency that we provide, really felt confident of taking it all the way. And they, in turn, obviously want to really provide value to their customers. And so getting validation for that, seeing that, yes, this was actually working very well for their customers, gives them the confidence then to continue on that path. I think that is just the beginning. So you kind of had this initial magical moment where everybody was just wowed by what LLMs could do. Then came, a bit of the throw of disillusionment to a degree to say, okay, but it can only do this and then not some other things, or how do you extend this? But the pace has actually kept up with, in terms of innovation of what the models could do, and so how much better they can actually get. I don't know how much further we need to go, how much further we will go in what amount of time. But I think where we are right now is certainly more than enough to actually get significantly more application and hence a lot more use out of these.
Yeah, I mean, Nick Frost said the same thing, that, it's good enough. It's like the iPhone 15. The technology is good enough now. And when you look at the kinds of things that people build in the enterprise, a lot of it's dashboards. They want to have a system where they've got all of my enterprise data connectors. I want to, do a pivot chart over here. I want to do like a profit and loss over here. I want to, look at my sales report or something. And just being able to construct that, publish it, run it on phones and so on, just kind of distribute it around. That would be amazing.
Yeah, absolutely. And it's funny you brought up not the fact that it's dashboards, but it's actually calling different things underneath. And so the more things you can auto-generate, so on one hand, you might be generating SQL. On the other hand, you might be generating an API call to something that then needs to give you an answer. So the better we keep getting at these, the more, I think, automated things will become, the easier it will be for just an agent. And, based on your particular workflow, to actually have an agent that is tailored to that workflow, even for the same sort of a user application, say two people in finance sitting side by side, or you and me acting as engineers, your workflow is guaranteed to be at least a bit different than mine. And so we can have an agent now that is tailored to exactly the way you operate. And so it's almost like a surrogate operating on your behalf, purely in a software sense. But I think that's actually possible now, and more feasible, and getting much, much better in quality by the day.
Yeah, I completely agree. I mean, there are certain things that LLMs are incredibly good at. In my view, the one thing that they're not so good at is abstraction. So it's almost like bridging those two worlds, letting the users define the domain model, the schema, the connections, and so on. And then within that, getting the LLMs to generate code and to connect things together and do the orchestration. That could be really exciting. I mean, two things in particular that I see improving as well are the user interface. So moving away from text.
Yeah.
Because language models, that they can schematize the answers, right? So we can have, a domain model, we can have certain types of products or offers or options or whatever it is, and then they can be visually represented. And the other thing is semi-automatization, automation, basically. So at the moment, everything needs to be completely supervised. But I think given the right tooling, we could start to semi-automate some of these processes.
Absolutely. And I think this is maybe a personal preference, but I actually like when things are semi-automated still, because it gives me a degree of control, because I like things, just so. But obviously that's not the case for everyone. And so the more we can actually have, the bigger the range and the ability to go from, not having automation to going potentially to full automation, you can pick and choose exactly where you want to be on that spectrum and say, this is what actually works for me. And I think coding assistants are a great example today of how this works. Obviously, you can just ask the model to generate the code entirely. It might work, it might not work. I think we have significantly better out-of-the-box code generation capability now. And of course, you have code-specific models that are much better than just the general models themselves. But the way coding assistants get used by an entry-level programmer versus a senior expert programmer is still significantly different. And so as a senior programmer, in your workflow, you know exactly what you want and you know exactly where you're going to let the model do things versus you doing things and how to actually expertly guide the model as well. So the kind of questions that you ask, where exactly you apply the model. And so are you asking it to write code from scratch? Are you asking questions on a piece of code? Are you editing just a particular piece of code? Are you asking it to refactor something? All of that matters. And so it doesn't take away from the fact that you're an expert. You really have that command of the domain. And so you actually are using the assistant or the LLM in a significantly different manner than somebody who's just coming in completely green. And I think that's always going to stay. And so the degree to which you use these assistive systems will probably just keep growing. But the ability to actually judge and then figure out what is enough, what to use it for, how much, all of that I think is still going to stay.
So who are your top customers? And I mean, I know you mentioned Fujitsu, but what are they doing with Cohere?
So Fujitsu, for example, is really wanting to apply large language models to all of their enterprise customers. It's a very well-respected, long-standing global enterprise. And so they have customers all around the world and not just in Japan. And so obviously one primary ask is, how do we really get, the primary language has been English. And so we started off with English for the most part, with most LLMs. How do we really get that level of ability also in other languages? And so I'm very happy that we focused on multilingual from the get-go, and then we're working with them to get even better at Japanese. You've spoken to Sarah Hooker before. She leads C4 AI for us, and with models like Aya, we are actually catering to even more, right? Of course, you don't necessarily have the need for all of those or an ask for all of those in a business context. And so with the commercial arm of Cohere, we focus on what is going to be the most useful from a business angle. So Oracle is a large customer for us. We have several others that are operating across multiple domains. So, for example, the same company will have use cases in human capital management or more HR-related things, in supply chain management, in ERP, in finance, in legal, in cases, in pretty much every domain that is related to corporate use, for example. So Oracle Fusion is a great example. Oracle NetSuite, both of these are very widely used suites of applications. And so Oracle uses the Cohere models to create functionality in several applications that are part of these suites. And so several use cases within each application that are part of these suites as well. And so they span quite a wide variety of domains. And then we have customers that are specific to a given domain as well. So some customers have use cases that are specific to finance. So we have TD Bank as a example of finance-centric use cases. We have others that are specific to insurance, specific to legal, specific to healthcare. And so I think the usage, the amount of customers who are just coming up with completely distinct, never before use cases has just exploded. And so the conversion from just thinking about a use case, figuring out applicability, to actually going full-blown to production, that had just gone up significantly in volume as well. LLMs are great, but are they actually giving businesses what they need? And so is this actually going to grow, or was it just a big spark? A spark, sure, a big one, but is it already fading away? It's like, no, this is barely scratching the surface still. This is merely the beginning. And so the there's a vast number of things that are going on under the surface that haven't come out yet. And the next 12 to 18 months is when they will all be coming out. So you're going to see an explosion of things that everybody thought of when they saw that initial promise, but they all take time to actually realize. I think the fact that you went from having a really good model that very few people were using to suddenly having ChatGPT and having it in everybody's hands, I think gave rise to this expectation that you would see the same explosion in business use as well. But the constraints are so much more. The expectations, the bar is so much higher over there that you can't have an overnight set of implementations. And some have done it, but they're definitely in the minority. And so the majority you're actually going to see come out over the next 12 to 18 months.
That's an interesting point because, ChatGPT was surprising. No one could see it coming. But are we now in this regime where we're dragging ourselves out of the Stone Age one step at a time and we know what we need to build? It just takes a long time. Yeah. Or are some of the things coming out going to be like, wow?
Yeah, I'll bet it's a mix. I think with enterprise use, many of the use cases that you already have today, they work fine with regular software engineering. They're going to be certainly turbocharged with LLM use because you can suddenly now get them to do much better than was ever possible. But you're also going to see a significant new number of use cases that just could not be possible before. And so we were talking about the cancer research part before. One of the biggest problems that talking to cancer researchers we found out is there's so much going on in terms of research and publications. It is literally impossible to keep up. And so even to the extent of finding somebody else who's worked on the exact thing that you are an expert on in the same institute. And so being able to even get that via just an LLM, say, hey, who else has worked on such and such, and knowing what that means, interpreting it the right way, figuring out the right search queries, fanning that out, getting the information, summarizing it, and then popping out, the 1, 2, or 3 names in the world or potentially in that institute is something that, doesn't seem like a big thing, but it is so impactful for that researcher. So they're like, oh my God, I had no idea that somebody down the same hallway, just 3 rooms down, was actually working on something that could be so helpful to what I'm doing and could actually lead to a breakthrough that would not have been possible otherwise. And so just that ability to process and make sense of information is something that LLMs are just blowing up. So I do think we're going to see a significant change in terms of how things are done pre-LLM versus now with LLMs. And so the volume of things that are actually going to come out, this is exactly what Cohere customers are doing.
Tell me about Cohere's growth over the last few years.
It's been amazing seeing the kind of growth we've had. We started off with when I came in 2 years ago, we were actually focused solely on developers. We hadn't actually made the transformation to focusing on enterprise, and that was one key piece that I felt was really critical coming in. My job as as SVP of engineering is to really make sure that we are applying this amazing technology in the way that customers find useful. And you and I, we have consumer apps, but then pretty much everything in the world of business is done via enterprises. And so we thought that would be the best way to really provide value. And so when we made the switch from only developers to actually going all the way to enterprises as well, we had to prioritize a bunch of things very differently. A lot of rigor, a lot more discipline, a lot more confirmation to what enterprises really needed from the model. And so that made its way all the way to how we were developing models. And so we've seen the results. So I think when I joined in 22, we had a number of customers that were trying to figure things out. They were dabbling. They were trying to see what LLMs could be used for. From that to 23, we had a increasingly higher number all through the year of customers who are trying to do proof of concepts, but on very real, actual, present, real-world use cases. And so the more value they got out of those, the more applications they actually put GenAI into. And so 2024, for a majority of those, is now turning into the year of production. And so one big example for us has been Oracle. And so we started a partnership with Oracle in 2023. and almost immediately had a large set of use cases that they felt GenAI would be very useful for. Obviously, for a large enterprise software with thousands of companies that are customers of theirs, it takes a while to actually roll things out. And so we've been able to help them put dozens of use cases into production in the first quarter. We worked with them, but then actually seeing that roll out to the first wave of customers, then the second wave, and then to the entirety of their customers, which measures in the high thousands in just companies, and then even more so in terms of actual users, has been fascinating. And so as they have that rollout go to more and more customers, they keep adding more use cases as well. And so we started off with, for example, human capital management, but then added sales, added supply chain management, and so and that was just initially in the Fusion suite of applications. But then also came NetSuite, which is very impactful and extremely widely used. And so now going to even further applications, both as part of Oracle Cloud Infrastructure, or OCI, which is the cloud arm, but also all of the other enterprise pieces of software that Oracle is known for. And so this is very accretive. And so you start off with a small number of use cases that you're just testing the waters with. Then the number of use cases grow, but then the amount of use for all of those also grows. And so quickly leads to an exponential explosion. And so that's what we're seeing with our largest customers already. And so 22 to 23, 23 to 24 is just a massive change for us.
What was the moment when people started taking LLM technology seriously?
That's a great question. I think the answer is probably different for consumers and for enterprises because I think when ChatGPT came out, I think that was definitely a defining moment for the entire industry. These models had been around for some time. Everybody in the know had taken notice of GPT-3. But then with ChatGPT, suddenly the more intuitive interface, the mode of interaction with LLMs suddenly made a big difference. So I think from just a humanity perspective, that's when people really took notice. But then beyond that came the moment of truth for enterprises. And so I think people really started paying attention in the enterprise world to LLMs when RAG really became the prevalent use case, because having an LLM generate something that seems creative or that seems very human-like is one thing, but not knowing whether it's real or not, not knowing whether it's verifiable or not, is a very different thing. And so no enterprise wants to take that risk. And so the trust, the security part of it, the reliability part of it, when we actually started to make sure that that was primary for LLM use, that's when enterprises really started to take notice.
So tell us about some of your customers.
I think we have a variety of customers. It's been great to see customers of all sizes really start to use generative AI, and I think the pace has been different in different industries, definitely with different verticals as well. But on one hand, we have very large enterprises as customers like Oracle, like Salesforce, like TD Bank. And we also have, innovative smaller customers like Borderless AI, Atomic Works, and Tab9. And so, what I see in common is HR as a domain definitely emerging a lot. Sales also being a primary one. Finance as well. With HR, we have a variety of use cases at Oracle, for example. But also with Borderless AI, they're using generative AI in many different ways to help with onboarding, to help with how team members at each of their customers are actually trained, even to the extent of figuring out certain things with payroll. With Tab9, you have a very different set of users. You have developers as users. And so Tab9 supports a number of different models, but especially with Cohere's R and R plus models, they use the models both to do code generation, but also code explanation. One of the standout features for R and R plus is the way they utilize context with data that is pulled in at runtime. And so our models are able to do extremely well consistently, even with a very large number of documents or with a large amount of data in the context. And so that is really important, for example, when you're pulling in code bases, or if you're asking a specific question that is relevant to a particular set of files. Being able to figure out the right things, get the right answer there matters a lot. And when you're coding, you obviously don't want this with a very large lag. You need the right extremely small latency so it doesn't actually disrupt your flow. And so with Cohere's models, Tabnine was able to do exactly that. So be able to get a very quick interactive ability to assist a developer in coding. So, and there's a lot more use cases, some of which I'm not allowed to say, unfortunately, but it's been amazing to see just the growing number of industries as well as the growing number of use cases across all of these. So I do think in the next year and a half, you're going to see so much more emerge publicly in terms of the usage as well.
Saurabh, it's been a pleasure. Thank you so much for coming on today.
Oh, thank you so much. This was a great conversation. I really enjoyed talking with you. And yeah, hopefully, we figured out some stuff that's useful.